Hello students, Ms. Slyman here with your first set of notes. This is in Unit 1, and this first example I'm going to be looking at how to solve linear systems. And we'll start with this first example. Actually, let's start with talking about the ways to solve linear systems. So I'm going to come in and make a new page here. And so thinking about our ways to solve linear systems, we have generally three or four different ways. So one of those ways is substitution, and then we also have elimination, and then we have graphing as well, and that includes graphing with technology. So hopefully you're familiar with these three different ways of solving. And if not, I'm going to start with a quick reminder of the ways of solving different equations. So let's go back and look at our different equations. So we want to use substitution when it's easy to isolate a variable. So substitution we're going to use when we can easily isolate a variable. And I can see that in this first example, it'd be super easy to get x by itself by just moving that 2y to the other side. So I'm going to start with that. So taking that first equation, we can say that x is equivalent to 2y plus 5. And now knowing that x is equivalent to this, that means in this same equation, I can substitute for the x with its equivalent expression. So I'm going to take this 2y plus 5, and now I'm going to put that, actually let's switch to highlighter. So I'm going to take x and replace this x value with the equivalent expression. So come back to my blue. In that second equation, I'm going to take 4, and instead of x, the equivalent expression is 2y plus 5 plus 3y equals 9. I'm going to distribute and collect like terms. 8y plus 20 plus 3y is 9. 11y plus 20 is 9. Subtract the 20 to the other side. 11y is equal to negative 11. That of course means that y must be negative 1. Now that I know what my y is, it's super easy to find my x because I know that x is equivalent to 2y plus 5, which must mean that x is the same as 3. 2 times negative 1 plus 5 is 3. So the solution to this system of equations at this singular point when x is equal to 3 and y is equal to negative 1, both of these equations are true. And I, of course, can test that. 3 minus 2 times negative 1, that's the same as 3 plus 2, which is 5. 4 times 3 is 12. 3 times negative 1 is negative 3. 12 minus 3 is 9. This point works for both equations. And that is solving by substitution.